Things has been facing many areas like information technology, healthcare, data analytics, and agriculture. In the previous lecture, you must have learned that Internet of Things is being used in every walk of life. It has reached, it has been introduced in every walk of our life. It is used in information technology, it is used in healthcare, in data analytics, in agriculture, and so on. And if something is widely used, then that thing has a lot of challenges as well. And those challenges are to be dealt with. These challenges are to be studied, are to be discussed, and then it is tried to resolve these challenges as well. While designing the IoT device, these challenges are kept in mind. While, while receiving and sending the data, challenges are kept in mind. While securing the data, these challenges are kept in mind. Where there is a issue of safety and security of a person, of an organization, of an institution, all the constraints and challenges are kept in mind. There are many challenges, some of them I have discussed here. First is scalability. As you know, as I have said earlier, that it is being used in every walk of life. So obviously, huge network of IoT is present in this world presently. The era of IoT evolution, everyday objects are connected with each other via internet. Okay? Billions of devices are connected in a huge network. Getting the point? Billions of devices. Because, as I said earlier, IoT has been reached in every walk of life. Every device has, nearly most of the devices are having the IoT device. And obviously, if a device is having the IoT device, if there is an IoT device, that device will send the data, it will receive the data, send the instruction, will receive the instruction. Okay. So billions of internet enabled devices get connected in a huge network. Obviously, large volume of data are needed to be processed. Billions of devices are sending the data, receiving the data. Then obviously, huge amount of data is to be processed, need to be processed every second. The system that stores, analyzes the data from these IoT devices need to be scalable. It should not be the case. Since last 1 month, I am having maximum of 500 GB of data in a day at particular time. So we don't need more than 2 gigahertz capacity of the system that could store, analyze and process the data. Might be someday a data burst have arrived, a data burst arrives of 3 gigahertz, 3 TB, then what will you do? What system will do? Huge amount of data will be discarded, huge amount of data will be lost. So the purpose of network will fail. So the system must be scalable. It must cope up the increase or decrease of data that is stored, that is analyzed. Okay. The raw data obtained from these devices need big data analytics and cloud storage for interpretation of useful data. Generally, devices give raw data. This data is processed, this data is filtered, this data is there are some processings are there which are done on that data. We will discuss it in later slides. So cloud and big data analytics, these two things are also incorporated for extracting the useful data from the raw data. Next thing is interoperability. Technological standards in most areas are still fragmented. A fragmentation means there are many devices which are using different technologies. For example, if we talk about networks, maybe some of the devices are using TCP/IP protocol, maybe some devices are using ATM protocol. Okay. Maybe some devices are using 802.11, some devices are using the standard 802.3, some devices are operating on 802.5, etc. and etc. These technologies need to be converged. Okay. Which would help us in establishing a common framework and standard for IoT devices. If devices are being operated on different protocols, different technological standards, it will be impossible to communicate with each other. The ATM device will not be able to communicate with TCP/IP device. So we must have to use some technology that converge all these different technological standards. Only then we will be able to establish a common framework for IoT devices, so that IoT devices operating on different standards could communicate with each other. Getting the point? Now, as the standardization process is still lacking, interoperability of IoT with legacy devices should be considered critical. Standardization process is still lacking for IoT devices actually. That's why interoperability of IoT operating on different standards is critical, and it is difficult by now. This lack of interoperability is preventing us to move towards the vision of truly connected everyday interoperable smart objects. This interoperability issue prevents us to use the IoT in more widely in the world. Okay. Next is lack of government support. Government and regulatory bodies like FDA should come up and bring up regulations by setting up a standard committee for safety and security of devices and people. There are there is one important challenge that for IoT devices there is lack of government support. For example, if we talk about GSM mobile devices, you purchase a mobile device from USA and you will be able to use and operate that mobile device in India. And if you purchase and make in India, made in India mobile and you go to USA, that mobile will work there also. Just because of government bodies of all the countries and the regulatory bodies have come up with some uniform standards, uniform regulations for GSM communication. Okay. So, here in this case of IoT, lack of government support is there for the safety and security of device and the people and the standards and the regulations. This is one of the important challenge. And the next is safety of the patients. Most of IoT devices are left unattended as they are connected with real world objects. If used on patients as wearable devices, any technical error in security can be life threatening. It happens in the hospital that a device attached to a patient in ICU and it is left unattended. Maybe if device corrupts abruptly, randomly, it may hurt the patient. Okay. Maybe the device could not send the signals to the concerned doctor and the device was unattended, it may hurt the patient. So, this is also one of the challenge. Next is security and personal privacy. There has been no research in security vulnerabilities and its improvements. By now, how much vulnerable the IoT devices are, there is very less research on this. This is one of the challenge. Anyways, nowadays a huge research is being started on this. Many researchers are doing the research on the security and the improvement of IoT devices and their process of collecting the data and so on. It should ensure confidentiality, integrity, availability of personal data of the patients. confidentiality of the patient, integrity of data of the patient, and availability of data of the patient. It should be ensured. It should not be leaked. Okay, it should not be corrupted, and it should be available as and when required, because it is a matter of life of a patient. For example, the data was required at the moment when the BP of the patient drops to 40 or 50, and the machine could not send the signal to the doctor, to the concerned doctor. It may be life threatening. Okay, so availability of the device is major concern. Integrity of the data of the patient is major concern, and confidentiality as well is also a major concern. Next is design based challenges. With the development in technology, design challenges are increasing at a faster rate. There have been issues regarding design like limited computation power, limited energy, limited memory, which need to be sorted out. Day by day, we are reducing the size of the device. And if we are reducing the size of the device, size of chips will be reduced. Size of battery which is there in the device will be smaller. And if the battery is smaller, then its capacity will also be lesser. If the device is smaller, then memory chip will be smaller, and if memory chip is small, then capacity of that memory chip will also be smaller. And if battery is smaller, computation will be more, then battery will be consumed very soon. So there are limitations of power computation, power management, limited memory, limited storage, etc. Okay, now come to the next slide. Now I am going to discuss some in brief some type of challenges. Like first is data security. As I have said earlier, there are many challenges about the design of the design of device, about data collection, data management, power size of the battery. There are many challenges. Now I am going to discuss some of the challenges in brief. First of all, I am going to discuss data security. The data, while data transmitted, how much it is safe. Data is collected by IoT device, and through internet it is sent to the server. So how much secure the media is on which data is being traversed. So some IoT devices collect highly sensitive data. As I said earlier, it may be the confidential data of patient, of a bank, of any office, and any government office, any ministerial office, etc., government ministry, etc. So some IoT devices collect highly sensitive information. IoT devices used in manufacturing have access to sensitive information about manufacturing processes and procedures. In the manufacturing units, IoT devices use some very sensitive information about the manufacturing process and procedures, some very precise information is being accessed from the system by IoT device or transmitted by IoT device to the server. For example, it might be if car is being designed in any manufacturing unit, uh, its body, its chassis, or its engine related information is being transmitted to the server by some IoT device or from server to IoT device. This is very sensitive information. Every millimeter, while designing an engine, while manufacturing an engine, every millimeter may produce huge loss. Okay. Anyway, so securing the data is a common challenge for IoT device. The data is accessed from public internet, as I told earlier, sent to the cloud-based servers. May or may not. It may be sent to the cloud-based server and web-based portals and managed by mobile device. It may be managed by the mobile device. Hence, they are less secure. When data is being sent on through web portals, through internet, managed by mobile devices, means data is traveling on local internet. Okay, on the internet, anybody can access. So, in that point of view, this data is less secure. Next, some common IoT security issues that can endanger the sensitive data that they contain include poor password security. There are some data security issues which are very common. First one is poor password security. IoT devices are often deployed with default, weak, and hard-coded passwords, keys, or secrets. Why it is kept so? Why the IoT devices are deployed with weak, default, and hard-coded passwords? If we put very strong key passwords and very complicated algorithms are being used to keep the passwords, then they will take much more energy from the battery to process, to decode or encode that passwords. Okay, that's why IoT devices are deployed with weak passwords. Cyber criminals exploit this poor password security mechanism to gain access to these devices. And cyber criminals exploit this, and they can access the data, they can alter the data, they can hack the data, and if anybody enters the data, you know what can be done. If it is the case of any patient, it can be life-threatening. That's why in previous slide it was said that the patient data should be confidential, okay, so that it may not be, it might not be used in other sense, in other way. Unpatched vulnerabilities. IoT devices are commonly deployed on a set it and forget it basis. In general, IoT devices are commonly deployed on set it forget it means IoT devices are and set it and forget it means the devices are, for example, as I have said earlier, uh, any IoT device is placed on a fridge, is implanted on a fridge. It is not being monitored every day whether it is working or not. Okay, so it is set it and forget it. Any IoT device implanted in a washing machine, in a fridge, or in any other place. So without it, for example, in 2020, I have implemented a IoT device in my washing machine. Okay, and that machine is being operated by me. In normal condition, IoT device is working properly. Okay, in 2022, a new virus is being introduced, but that device which is installed in my washing machine is not capable of filtering, sorting the newly generated virus. Okay, so there should be some system that every 6 months or every month, if there are some patches, they could be installed in that IoT device. As you have seen, normally you must have seen in your mobile devices that a notification pops up, software update notification or app update notification, WhatsApp update, PNB Bank app update, Beam UPI app update, your any game app update. Okay, these are what? These are patches. Okay, sometimes you see, you go to the Google Play Store and you want to see what type of patch is there, what type of update is there, and you see the description of that update, you see some security enhancement. Okay, so IoT devices must be compatible to be upgraded with regular patches. IoT devices are commonly deployed on set it and forget it basis without patches applied for newly discovered vulnerabilities. As a result, many IoT devices contain vulnerabilities that an attacker can exploit. Okay?
Now, come to the next point related to data security, that is lack of encryption. Encryption is very useful way to prevent the data from hackers. If data is encrypted, it's very tough for hackers to access the data, to understand the data. It is, but it is also one of the leading IoT security challenge because encryption algorithms are complex. If you want to encrypt data with high security, obviously we will have to implement more complex algorithm And if algorithm is complex, then it will have to make more effort for an IoT device to encode and decode the data. And if IoT device is applying more effort, then obviously power management will become an issue. More power will be required to encode and decode and process the algorithm of encryption. So this is also one of the important challenge. Next is insufficient testing and updating. With the increase in number of IoT devices, IoT manufacturers are more eager to produce and deliver their devices as fast as they can without giving security too much of their concern. If something is in demand, then manufacturing companies want to produce more and more devices, more and more items, and float into the market so that they can capture the market. Okay, at that point, they don't bother for these type of concerns that how much secure it should be, how much should be the availability of the device, how what are the security challenges, and what and these security challenges whether they are kept in mind while making the design of that device, etc. Okay, most of these devices and IoT products do not get enough testing and updates and are prone to hackers and other security issues. You must have seen nearly 5 to 6 years back that in the market Chinese mobiles, so Chinese mobile of very less price, nearly 3,000, 4,000, and such type of Chinese phones are there in the market. But after some time, after 1 or 2 years, government of India banned all those because they were of only 14-digit EMI number, and it became very difficult for government of India and the government agencies to track these mobiles because all the standard uh, MSCs, all the standards of mobile companies are compatible with 16-digit EMI number, and that Chinese companies were giving the mobile with 14-digit. That's why government of India banned importing all such devices. So this is one of the issue. Even something is in demand, companies don't bother for updating them, companies don't bother for sufficient testing. Okay, now till now I was discussing about security of data. Now I'm coming to the next point, that is also a very important challenge for IT devices, and this is data privacy. Much of the information collected and processed by IoT device may be protected under various data privacy law, including their name, address, phone number, medical data, and more. So, many of the IoT devices are given the name, address, phone number, medical data, and some other secret informations, and these information must be kept private. as I have told in last to last slide, in case of medical or patient's case, that personal information of patient should not be leaked. Okay, so most IoT devices are likely to gather at least one type of protected information. Some important consideration include uh, here I want to say that at least one of the private information is to be shared with IoT devices. So sometimes one and sometimes more than one uh, information are to be shared with the IoT device. An IoT device is sharing the information to the cloud, and that cloud is connected to IoT device with internet. Means data is traveling on internet, and if data is traveling on internet, this is unsafe. Okay, anybody can access and use it. So first of all, consent to the collection. Government makes some laws, privacy laws for banks, for so many things. For example, when you open your account in Google, for you and when you open your account in Facebook and Gmail, then they ask your phone number, your date of birth, and if you don't want to share your phone number to the public, date of birth to the public, then there is a checkbox. Make it hide my age, hide my date of birth, hide my phone number, etc. There is option. Means they take your consent. Facebook, Gmail, they take your consent to public that data or not, or to keep it private. And if you check the box that keep my phone number and date of birth private, uh, then on your Facebook page, these information will not be displayed. So personal data must be collected with the consent of the a person. Next is consent to processing. As per laws, explicit consent is required from data subjects for their data to be processed. In recent years, you must have seen while filling some forms or at the time at the time of filling ITR uh, online, you check box the account verification by Aadhaar. You tick that uh, button and click submit. Means you give your consent to process, to execute this verification process through your Aadhaar. And when you when you check this, then a message of OTP comes to your mobile or your email ID, etc. and etc. This makes the processing of IoT device more challenging. And this process, all these taking consents makes the IoT device more challenging. The design of the IoT device becomes more challenging. The processing of IoT device becomes more challenging because it takes too much time. Okay. Now come to the encryption. Here, encryption in case of data privacy. Data protection laws require data to be encrypted at rest and in transit to protect against unauthorized access and misuse. Means data protection law says data should be kept encrypted at rest. At rest means when it is there at some organization At that moment, it should be encrypted. For example, your bank account password is there at your bank server. When you enter your password, the entered password and saved password both are matched, and if both are matched, then your account opens. Okay, so the password stored at the bank server is at rest, and you enter the password that goes through internet. This is in transit. Okay, so the data at rest and in transit should be protected so that unauthorized user could not access and misuse it. IoT devices often have limited power and processing resources, making appropriate data encryption difficult. IoT devices are small devices. They have limited size of battery. They have limited power, and every time when you use the device, when device processes something, its battery is consumed. Okay, so this makes, and if you are using encryption, decryption, and all that activities, it will take more activities to be done, more instructions will be performed, and if instructions are performed, then obviously more battery will be consumed. For example, uh, your mobile device, it is 100% charged. Okay, you charge your device, your mobile device, and take it off and put in the almirah. Okay, and after 1 month you open your mobile will be 100% charged. Okay, because it was off, no activity was done on that mobile, neither uh, nothing. Okay, and another case, you charge your mobile 100% and remain it on, and after 10 days you see that the battery is only 50% or 40% or 30%. However, you haven't touched your mobile. You you charged your mobile 100% and kept it in the almirah, and after 10 days you picked it up and seen that it is 100%, 50% discharged. Why? How? You haven't done anything. Even then it is 50% discharge. How it is possible? This is possible because while mobile is on and there are many activities which are being done in the mobile. For example, somebody called me, but that mobile was means someone called me, not that mobile, but the matching of address was done at my mobile as well as at that mobile, but address didn't matched, it did not match with that mobile, so its bell did not ring. But address matched with my mobile rang. Got the point? Okay. uh, for example, you all are there in the class, 50 people are there, I called only one person, 49, only one mobile will ring, rest remaining 49 mobile will not ring. But the processing of matching of address will be done on all 49 mobiles. Obviously battery will be consumed in that case, na? Okay, so battery is consumed. if the device is on and activities, hidden activities, there are many hidden activities which are processed, and in that activities battery is consumed. Now come to next point, access management. Data protection laws restrict access to sensitive information. Okay. These laws are framed and implemented by the government. Okay. In every country, laws are different. Okay. In India, different laws are there to for protecting the data, for accessing the data. In US, there are some different laws for accessing the data and protecting the data, etc. IoT devices are designed to be distributed and have their data processed on cloud server, making it more difficult to track and control access. IoT devices are designed in such a way that uh, because IoT devices are distributed and they are designed in such a way that they process their data in the cloud servers. Okay, so when your data IoT device is a very small device, it has a limited amount of memory, so it keeps large amount of data to the at the server, cloud servers, and it becomes very difficult for IoT device to track and control the access of that data, because every time device needs some data, it will have to send a request to the cloud server that please send me so and so data. That will send the data to the device. It will take some time. Okay. Now come to the next point, that is data volume. You see, everywhere IoT device is being used, and these devices produce massive amount of data, huge amount of data. IoT devices are commonly deployed in remote locations with limited internet bandwidth. This makes it very difficult, and often it makes it very expensive to transmit the collected data. They produce massive amount of data first of all, and this massive data is to be transmitted to the cloud server, and if the device is installed in remote area, in village area, then it becomes very difficult, because internet bandwidth issue is there in countryside area and remote areas. So due to bandwidth restriction, it becomes very difficult and expensive to transmit the data to the cloud server, and data volume is very large. Each click of time, data is transmitted. Okay, in the cloud, servers must rapidly process and analyze growing volumes of data to extract essential insights and send any required alerts or command to the IoT device. And at the cloud server side, they must process and analyze this data. Data is at the cloud, data is coming at very high speed, and very large amount of data, and cloud server has to filter that data to to raw data, and convert raw data to useful data, then analyze the data and again transmit it to IoT device. Okay. So must cloud server should be able to do all these things very rapidly. to handle this huge amount of large volume of data. Okay. Next is data complexity. Many IoT devices are designed to adopt a big data mentality. Data nowadays, data is very big. In last uh, many slides, I have said nearly each and every slide has spoken that huge data is there, large volume of data is there, and this large volume data is called big data. So many IoT devices are designed to adopt big data mentality. These devices collect as much information as possible and send it to cloud-based server for processing that I have told earlier in the previous slide. In addition to producing massive volume of data, this approach also creates complex data sets. Data is huge and data is complex as well. Okay, and this huge data, complex data, this is to be handled by IoT device. This is very important and very difficult challenge for the designer of IoT devices. The data produced by IoT device is often unstructured and provides a limited perspective. I've, uh, I've told the cloud servers convert the raw data into the useful data. Okay? We will come to the this thing, what is raw data, what is useful data. Anyway, so this raw data is unstructured data. IoT device is often unstructured and provides a limited perspective. We, the cloud server, make it useful. Then it gives proper perspective. Okay. This data must be carefully time-stamped, indexed, and correlated with other data sources to make the context required for effective decision making. This is useful data. Raw data was something. Cloud modifies, converts that raw data into the useful data, which is used in effective decision making. Okay, this data must be carefully time stamped, indexed, correlated. Time stamped means at 10:10 data is sent, 10:11 is again data is sent, 10:11 data reached first, 10:10 data reached after 10:11. This will be very difficult for cloud server to make it useful. Okay, so data must be time stamped. Every data must have a timestamp that this was produced at 10 a.m. and this file, this bunch of data was created at 10:11. This bunch is this packet or this bunch of data is created at 10 to 12, etc. And it should be indexed as well. Means for a huge amount of data, that this thing you must have studied in computer networks. A huge file is divided into segments, and that segment is divided into packets, and packets are divided into frames, etc. And all are sequenced. Fragments, segments have specific sequence numbers. Packets have specific sequence number. Frames have specific sequence numbers. Okay, so that at the end, at the receiver end, they should be they should be integrated in one packet as sent at the sent from the sender end. Okay, for example, packet number 4 has six parts: 4.1, 4.2, 4.3, 4.5, 4.6. Okay, so they should be indexed that this frame of packet is 4.2, this frame of packet is 4.3, etc. And at the receiver end, if 4.2 reached before 4.1 and 4.1 reaches late, even then receiver and destination and cloud server end will be able to uh, integrate in proper sequence 4.1, 4.2, if all the frames would be properly indexed, and they should be correlated. Obviously, if I am talking about mangoes, then at 10 frames about the mangoes, then all the packets should be about the mangoes. There should not be any packet of tuberculosis, a report of any patient. For example, 10 packets of mango and 9 packet of mango and one packet of tuberculosis report of some patient. Okay, so data should be correlated, uh, so that effective decision making could be done. This data volume and complexity combination makes it very difficult to effectively and efficiently process data from IoT devices. You must have understood this thing. On the other hand, solutions that can handle massive volume of data may not offer the required level of in-depth analysis and may not meet the latency requirement of the IoT device. See, if you are saying that my device is capable of handling huge amount of data, massive volume of data, okay, it's okay, it can handle. But if the cloud is handling massive amount of data, then it will take some time to process, to analyze the data. And if it is doing in-depth analysis of the raw data, then obviously it will take time. So latency requirement will not be fulfilled. Okay, and if latency requirement is fulfilled, then obviously it, cloud server will not be able to do the in-depth analysis. Okay, so these are very important challenges. This thing I've said many times. I've taken this word many times: battery life, battery constraint. The use of battery power necessitates numerous compromises in terms of connectivity technology use, communication protocols, processing, and more and more. The technology, the complexity, the analysis, all these things consumes battery. All activity, every activity consumes battery. Okay, so battery is required for each and every activity. Okay, whether it is connectivity technology or implementing some protocol, processing the data, analyzing the data, encrypting the data, decrypting the data, matching the address, everything will consume some battery. If activity is small amount of battery will be consumed. If activity is complex and large amount of battery will be consumed. Okay, many devices run for months or years on a single battery. For example, if we talk about IoT device installed on some fridge or AC or in washing machine, whenever you switch on the in general fridge is always on, and there is no constraint of battery power, because if fridge is on, the device is getting the power 24 hours. And in case of washing machine or in case of AC, whenever the device is on, the AC or washing machine is on, the IoT device is getting the power from them. But in case of wireless devices which are installed in a farm for agriculture use, and in forest, in um, war-like situations, their wireless devices are being installed, and in that case, battery is very important aspect. You know, therefore, manufacturers go to great length to reduce energy consumption. In that case, if for case of wireless devices, manufacturers try to uh, simplify the activities of IoT device so that less power consumption is there. Other thing is, they also reduce the energy consumption by hibernating the device. Hibernating means whenever you are not using they in your mobile, if you don't access your mobile for 15 seconds, it goes into the sleep condition. Okay, you don't touch your mouse pad of laptop or touch any key of the laptop, it goes into the sleep or goes into the hibernation condition. So battery is conserved. So to reduce energy consumption by hibernating the device and minimizing the use of high power radio chips like Wi-Fi. Okay, Wi-Fi devices use power consumption. So, manufacturer, the motto of manufacturer is to enlarge, to extend the length of battery life. For this, they try to keep the complexity lesser of the device. For technology point of view, protocol point of view, encryption decryption point of view, okay, and by taking the device in hibernation, in sleep mode, while it is not in use. This particularly influences connectivity. Power conserving devices will periodically connect, send and receive the data, then disconnect, shut down the radio interface, and put the processor to sleep until later. When, when it will be required, it will again awake, and again it will send a request, and it will get the response and transmit the data, etc. Okay. Next point is increased cost. For IoT devices, there is constant pressure to minimize the cost of all the components. Every device, everywhere it is being used, everywhere it is used. So it is required to make the cost of IoT device cheaper. Otherwise, the cost of device on which the IoT device is installed will become more. Inevitably, IoT developers will want to build a solution as cheap as possible, either improving margins or allowing for cheaper prices and therefore wider adoption. Obviously, if price will be cheaper, price price will be lesser, many more devices will be able to install the IoT device on their device. So adoption will be wider. It is already wider, but even then it is costlier, not so cheaper. For an organization operating a small number of devices, the cost is small. But for deployments to thousands of devices, the cost of data can rapidly become significant, obviously. Okay. So, this is also a challenge that cost should be cheaper, cost should be lesser, so that it could be adopted everywhere. Okay. Now come to the deployment challenges in IoT. Where it is to be deployed, where it is to be installed, what are the challenges in that case. First of all, connectivity. It is foremost concern while connecting devices, applications, and cloud platforms. Connected devices that provide useful front and information are extremely valuable. But poor connectivity becomes a challenge where IoT sensors are not required to monitor, process the data, and supply information. I have told you in previous previous slide that in countryside it becomes very difficult due to bandwidth restriction to transmit the data, to handle huge amount of data and large volume of data. So connectivity is very important issue. The device is installed, is deployed in an area where bandwidth is an issue. Okay, so it is very difficult for sensors, for IoT devices to cope up with the real time situation. Poor connectivity becomes a challenge. Okay, where IoT devices are required to monitor, process the data, and supply information. Next is cross-platform compatibility capability. IoT applications, sorry, IoT applications must be deployed keeping in mind that the technological changes in the future. It its deployment requires a balance of hardware and software functions. This should be kept in mind while deploying the IoT device. There that the technology is changing very rapidly. There are many cases. In positive point, technology is changing very rapidly. Updates should be patches should be installed, and in other sense, as technology is advancing very rapidly, viruses, hacking technologies are also growing very fast. So this should be kept in mind. Uh, its development requires a balance of hardware and software function. It is a challenge for IoT application developers to ensure the device and IoT platform drivers the best performance despite heavy device rates and fixings. All type of problems, fixings, device rates. So this should be kept in mind, the device which are installed in the area, on what platform it is going to be operated, and so on. Data collection and processing. In IoT development, data plays an important role, that I have told many times. What is more critical here is the processing or usefulness of stored data. Along with security and privacy, development teams need to ensure that they plan well way for the way data is collected. Okay? How data will be stored, how data will be processed within an environment. There are different environment. In countryside, environment is different. In India, environment is different. In Australia, environment is different. Okay, in India, there are different type of threats. In US, there may be some different type of threats. All these things should be kept in mind. Okay, lack of skill set, all the developments, all of the development challenges above can only be handled if there is a proper skilled resources working on the IoT application development. Things that I have discussed so far, all the challenges I have discussed so far, all the restrictions, all the constraints I have discussed so far can be resolved, can be resolved only if you have proper skilled resources. The right talent will always get you past the major challenges and will be an important IoT application development assets. So these were the IoT challenges I've discussed with you. Uh, IoT devices are being used everywhere, every walks of our life. Huge data is processed. We require a rapid request and response process for IoT devices. For that purpose, we must have uh, very efficient and effective devices, communication media, effective and efficient cloud servers, and all these things should be secure. They should keep the data private. They should confidentiality should be maintained. Integrity of the data should be maintained. Privacy should be maintained. Okay, all these things, how to where to deploy, how to deploy the device. Okay, and what will be the bandwidth issues, all these things I have discussed, and all these things are very important and major challenges in uh, point of view of IoT devices and IoT technology. So in the last, as I've said, there should be very skilled resources, skilled personnel to handle all these things, very skilled personnel design to design and handle all these things. Okay. These were the IoT challenges. Now, if anyone has any question, please ask. I'm here to reply anyone. There is also a confusion in between IoT and WS regarding the difference between IoT and wireless sensor networks. There is always a confusion. Some people say IoT is WSN. Some people say WSN is IoT. Some people say IoT is subset of WSN. Some people say WSN is a subset of IoT. Now, here We will discuss this thing and all the confusions will be clear. First difference between IoT and WSN is internet connectivity. In an IoT, all of the sensors directly send their information to the internet. All the IoT devices transmit the data, the collected data, to internet directly by their own. Okay, by their own. For example, a sensor may be used to monitor the temperature of a body of a water. If temperature varies, if suppose there is a setting, if temperature goes above 30 degree, there should be a signal. If temperature downs below 10 degree, there should be a signal, there should be an alarm. In such cases, the data will be immediately or periodically sent directly to the internet. Suppose that sensor is connected to my mobile, then on my mobile there will be an alarm, there will be a notification that in your water body the temperature has raising beyond 30 degree, or it is getting down below 10 degree. Getting the point? So one more thing, IoT devices either immediately send the data or periodically send the data as required. In some time, in some situations, immediate data is required. For example, in the case of patients, if BP is getting down, oxygen level is getting down, immediate alarm is required. Immediate alarm is to be sent to the concerned doctor. In that case, periodic transmission is not acceptable. It is a case of life of human being. If periodic time is, for example, 10 minutes, then patient will go up above the word so high in 10 minutes. Okay. So there are different conditions, either immediately or periodically. Okay. Depending upon the condition, situation. For example, an IoT device implanted on in the fridge, and there is a setting that if milk pouches, 1 kg milk pouches reduces to 1 pouch, there should be an alarm. There is no need of immediate alarm. The IoT device can check the content of milk, the quantity of milk within the fridge after 1 hour. There is no need of checking the quantity of milk every tick of time. Okay, but in case of healthcare system, it is to be checked and transmitted immediately anyway. So where a server can process the data and it can be interpreted on a front end interface. Okay, data will be sent directly to the internet and it can be interpreted on the front end interface. Conversely, in a WSN, there is no direct connection to the internet. Okay, there is no direct connection to the internet. Instead, the various sensors connect to some kind of router or a central node. Some sensors are deployed in an area and all the sensors are connected to some actuator or central node, and that central node is connected to the internet through gateway. A person may then route the data from the router or central node as they see fit. Whenever there will be requirement, or router or central node sees fit that this much of data should be transmitted to the server, to the internet through gateway, then it will send. That being said, an IoT system can utilize a wireless sensor network by communicating with its router or gather data. Uh, Read it, mind it. An IoT system can utilize a wireless sensor network. Now, you will be able to clear this thing. It will be cleared in your mind that which is subset of which one. Okay. IoT is utilizing the wireless sensor network by communicating with its router to gather the data. Getting the point? And IoT exists. IoT as a subset of, sorry, WSN as a subset of IoT that I have told in previous slide. Okay, previous point. IoT exists at a higher level than WSN that I have told you in last line. In other words, WSN is often a technology used within an IoT system. Means IoT is a large system, huge system in which WSN is a subset. IoT exploits WSN technology. Okay? Not only WSN technology, WSN and some other technology. I will discuss it in next point. A large collection of sensors, as in a mesh network, can be used to individually gather data and send data through a router to the internet in an IoT system. Many sensors are deployed in an area. They are collecting the data. Okay. After collecting the data, they are giving that data to the coordinator node, sync node, or actuator node. This is giving that data, the central node is giving that data to the router is giving that data to the gateway, and gateway is transmitting that data on internet. Okay. WSN consists of a network of only wireless sensors. That's why in previous point I had said that IoT exploits WSN, not only WSN. It is using something other than WSN. WSN is, W means wireless. Okay. That's why in second point I am emphasizing that WSN consists of a network of only wireless sensors. But IoT is not. Okay. If the network was to include a wired sensors, it could not no longer be said as wireless sensor network. Suppose there is a network in which there are some wireless sensors and some wired sensors. Okay, then the network of wireless sensors will be termed as WSN, wireless sensor network. But the sensor which is connected through wire cannot be part of wireless sensor network. Okay, that will be part of wired network. For example, the Wi-Fi system of your university, there are some access points installed on the walls, and these access points, the access point, or you can say the Wi-Fi point, these access points are connected through fiber or cable to a backbone. That part is wired network. That backbone is wired network. And the devices, the mobiles, the laptops, which are accessing the wireless access from the walls, from the access point, is part of Wi-Fi network, wireless network. Okay, it could no longer be labeled as wireless sensor network. Essentially, any device that connects to the internet can be considered an IoT device. Any device that is connected to internet can be considered as IoT device. There is some exception I will discuss. An IoT system can therefore be interpreted as group of many IoT device. Many IoT device comprises a IoT system. An IoT device is connected to internet. IoT device, if IoT device is connected through wire to the internet, then it is part of wired network. If IoT device is connected to internet through wireless technology, then it is wireless sensor network. Maybe the wireless sensor network. Okay. Now, some examples. For example, a fridge with the capability of sending the temperature regarding to the internet is unlikely to use a wireless sensor network, but it is an IoT device. The IoT device installed in the fridge, the temperature sensor, the weight sensor for keeping track of milk quantity, and so on, or some other type RFID sensors to maintain the quantity of things within the fridge. They are installed, deployed on the fridge. So, to the internet, the fridge with the capability of sending temperature reading to the internet is unlikely to use a wireless sensor, but it is a IoT device. That fridge, that IoT device installed on the fridge may be connected through wireless network or may be connected through wired network. If it is through wired network or some Wi-Fi network, then it will not be an a WSN. Okay, because if that IoT device, a fridge, is connected to Wi-Fi access point, that means it is giving the signals wirelessly to the access point, but access point is directly connected to internet through wired technology. Getting the point? Anyway, a large connection of sensors used to monitor precipitation on the acres of land is likely to be considered as wireless sensor network. In agriculture field, many sensors are deployed for monitoring the precipitation and soil conditions. Such type of sensors form wireless sensor network. In fact, all sensors are wireless. Okay, this system may or may not be connected to an IoT system. This system may or may not be connected to an means IoT means these sensors may not be directly connected to some internet because there is no requirement of immediate response. Okay, uh, these sensors collect data somewhere at the actuator node or sync node, and that sync node can be accessed periodically, twice a day, once a week, because the purpose is to sense the moisture, to sense the precipitation, to sense the other things, other features of soil. These features of soil, these characteristics of soil, these precipitation on the soil will not change minute by minute. Okay? Now, uh, now Internet of Things, the connection. I've said earlier that in previous slide, any device that any device that connects to internet can be considered as an IoT device. Mentioning this point, I have said that there are some exceptions. Come to this. The connections of devices generally not include smartphones, laptops, PCs, etc. These devices are not considered as IoT device. Okay, laptops, PCs, smartphones, tablets. Okay, these devices are not considered as IoT devices. Additionally, as Business Insider puts in, any standalone internet connected device other than the above mentioned that can be monitored and or controlled from a remote location is considered as IoT device. Standalone device which is controlled and monitored, accessed from a remote location is said as IoT device. What is WSN network? WSN, a collection of wireless sensors that may or may not be connected to internet is WSN. How WSN is deployed? A WSN can generally be described as a network of nodes that cooperatively sense and control the environment, enabling interaction between persons or computers and the surrounding environment. This is an area, this is an area where some sensors are deployed. They are wireless sensors. They are being shown as connected to each other by blue line. This doesn't mean that they are connected through wire. This blue line connecting two brown circles are sensor nodes, and the blue line is not the sensor node. Blue line is communication. Two nodes. Two lines is representing the connection between the nodes, not the connection oriented connection. Okay, not the wired connection. Sorry, not connection oriented. It is not the wired connection. Okay, it is connection, wireless connection. So a WSN can generally be described as a network of nodes that cooperatively means they are cooperating to each other. How they will cooperate to each other? They will share the data. They will communicate to each other. That's why blue line is being depicted. Okay, shown. They are cooperatively sense and control the environment, enabling interaction between person or computer and the surrounding environment. The wireless sensor network, this is a wireless sensor field or area. Sensor nodes are deployed. There may be some routers. There are some gateways. WSN nowadays you usually include sensor node, actuator node, or you can say the coordinator nodes, routers, gateways, and clients. Routers, which defines the route. What is the purpose of gateway? Know everyone? I think all of you must have studied computer networks, data communication. You all must be knowing the what is the purpose of gateway. Gateway is used to make the data compatible of one network with the other network. Suppose uh, one network of TCP IP want to communicate with other network of ATM protocol. One network N1 is using TCP IP protocol and other one is using ATM protocol. Will it be possible? Hindi speaking person can communicate with Chinese speaking person? Impossible. There should be a gateway in between Hindi and Chinese speaking persons. The gateway, what gateway will do here, the content from Hindi he will take and he will convert that content into Chinese and convey to the Chinese person. So the translator, the intermediary person, will convert Hindi content to Chinese content. This processing, Hindi to Chinese, will be done at translator level. This is the function of gateway. Gateway converts Hindi to Chinese. You get them. Okay. Now there are some hindrances within the anyway. Uh, Now come to WSN technology. Sensor node, wireless sensor node. It has is one of the main part of WSN because without this sensor network could not exist. The hardware of sensor node generally include four parts. Number one, power and power management means power means battery and battery management. Number two, a sensor obviously, a microcontroller or microprocessor you can say, and then is transceivers. You see, battery power and power management part is shown very big block with shown with very big block because it is very important aspect. Power and power management. In case of sensor, it is very important. For example, you have put a small sensor within the skin of a fish, and fish has been um, thrown in the river or in sea to sense the condition and see the um, environments and threats from the sea, within the sea. So suppose the life of fish is 1 year, and fortunately it is not been swallowed by some other fish. So the battery, you will not track, you will not tied that fish with some thread, and after 2 days you will take out that fish and change the battery or charge the battery. You will not do that. You will throw the fish in the sea and leave it. Wherever it will go, it will give you the information. Sometimes, for defense purposes, sensors are put within the skin of animals, within the shoes, within the dress of army personnel. Okay. Anyway, so the power and power management is very important aspect in case of WSM. Okay. So there are sensors. First of all, the power and power management, battery and power management. Power is battery. Power management is, as I have told in the previous lecture, that sleep mode, hibernation, keep the sensor not very complex, so that lesser activities, that less complex activities should be implemented so as to conserve the power and so on. Next thing is sensor, which will sense the data. Sensors are of many types. I will show you some of them, and in lectures taken by Shish sir, you will be able to see the temperature sensor, the sound sensor, the light sensors, etc. There are many more sensors, motion sensors, etc. Next, microcontroller. Sensor will sense the data. Microcontroller or microprocessor will process the data, and transceiver will send the data or receive the data. Getting the point? Some sensors are kinetic, or you can say motion sensor, solar sensor, thermal sensor, or you can say temperature sensor, light sensor. Okay, many more sensors. Access technology. A large number of sensor nodes deployed randomly inside of or near the monitoring area and form network through self-organization. Sensors are um, deployed randomly. They form the topology, they form the network by self-organization. Suppose if sensors are put within the skins of the animal, the elephants, then the network will be according to the position of elephants. One elephant is going towards east, one is going towards west, the topology will change. Okay, the transmission range is up to some 100 meters to few kilometers, depending upon the type of sensor. There are some very sensitive and high end sensors of which the transmission range is higher, up to few kilometers, and there are some um, cheaper sensors uh, which are used in laboratory of your level, not at research level laboratories, at simple graduation level laboratories. As you will see in the next lectures by Sir, their range is not, they are not too much sensitive. Okay. Anyway, backbone network usually uses optical fiber structure with a high transmission range. I have said earlier, told you that your a university Wi-Fi, the access points are connected through optical fiber. Similarly, the backbone network of WSN is made up of optical fiber, because optical fiber is uh, most efficient and most effective in comparison to coax cable or twisted pair backbone. Okay. WSN topology, I have said topology is not fixed in case of WSN. It may change, it may vary. You can't say that it is in one line, it is in the form of square, it is in the form of hexagon, it is in the form of pentagon. You can't say. Topology will change, but the technique may be used in these three ways. Position of 1, 2, 3 may different, but all are sending the data to sync node. Then this is star WSN topology. Might be they are in the in one line, but 1, 2, 3, 4, 1, 2, 3, 4, all are in one line, but sending to one sync node, then it is star topology. Getting the point? And tree WSN topologies, some WSN nodes are sending the data to specific actuator node, and that actuator node is giving the data to some router, and router is giving some other coordinator node or router node, and that coordinator node, for example 5, is giving the data to sync node. Then this is tree WSN topology. Again I am saying, position, location may differ, but technique to transfer the data forms a topology. Getting that point? Now, next is change WSN topology. All are one is giving data to 2, 2 is giving to 3, 3 is giving to 4, 4 is giving to 5, and finally 5 is transmitting data to sync node. Then it is chain WSN topology. Now come to the next point, IoT enabling technologies. How IoT is enabled? How IoT comes into existence? What are the engine and wheel and steering of the IoTs? These are major things without which IoT doesn't exist. Number one is a wireless sensor network. In this, I will want to add wireless, not necessarily only wireless, not necessarily only wireless. It may have some wired sensors as well. Okay. Second is cloud computing is also the major thing for enabling the IoT. Next is big data analytics, communication protocols, and embedded systems. These are the hearts and minds of IoT. Okay? In brief, I will discuss each and every point in very brief, because each and every point, all the 5 points, are huge subjects by in their own, huge subjects in their own. Okay, now, so I discuss each and every point in very brief. First is that WSN. I've discussed in detail about the WSN. It comprises distributed devices with sensors which are used to monitor the environmental and physical conditions. All these things I have discussed earlier. A wireless sensor network consists of end nodes, routers, coordinator that I have shown depicted in the figure in last slides. End nodes have several sensors attached to them where the data is passed to a coordinator with the help of router. The coordinator also acts as a gateway that connects WSN to the internet. Here you see the purpose of gateway. Remind, WSN is different technology, internet is different technology, and in between it is working as translator, Hindi to Chinese translator. WSN, the data received from WSN is transmitted to internet through gateway. Okay, examples: weather monitoring system, indoor air quality monitoring system, soil moisture monitoring system, surveillance system, health monitoring system, and many more systems. Many more systems. You There is a sky is the limit. You can't mention here in slides, because I have said earlier, this IoT and WSN, this IoT is being used in every walk of life. Okay. Anyway, WSN is used in these things. Some of the examples are here. Next point is cloud computing. It provides us the means by which we can access application as utilities over the internet. You all are aware, well aware about the cloud. You must have heard, I think, in since last 5 to 7 years, cloud is very common and general word. It has become very common word. Cloud means something which is present in a remote location. Okay, this is cloud. For example, your Gmail. You are opening your Gmail on your mobile, but you are accessing that mail from the Gmail server. The data of your mail is not present in your mobile device. It is being accessed from the Gmail server. Okay? So, data is present at the remote location. You are accessing that data from the remote location on your mobile, on your laptop. Getting the point? This is cloud. With cloud computing, users can access any resource from anywhere, like databases, web servers, storage, devices, and any software over the internet. Using cloud computing, you can access anything through internet. You can access any software, you can access any database, you can access any web server, you can access any storage, you can access even any device from remote login. Okay, all these things happen through cloud computing. You are putting your ATM into some ATM machine. You have the ATM of SBI and you are putting that SBI ATM into the PNB ATM machine. Your account is of SBI, your ATM is of SBI, but you are inserting that ATM into the PNB ATM machine. Even then you are getting money. How it is possible? That PNB ATM machine doesn't know anything about your SBI account. Even if you go to the bank physically and you say that I have my account in SBI and it has 1 lakh of rupees and I want to withdraw 50,000 from them, from that account, that clerk will that clerk give you some money? No. He will laugh at you and say, छोटे बच्चे हो क्या, इतना भी नहीं पता. Getting the point? So, uh, but in case of ATM, it is possible just because of cloud computing. Okay. This is a long story how this is processed. SBI ATM can withdraw amount from PNB ATM machine. This is a long story. I'm not going inside this story. Anyway, cloud computing, it has some characteristics. First is broad network access. Obviously, broad network access. Number two is on-demand self-service. As and when required, data is available to you. You can access your email in 2 a.m. night, in 4 p.m. evening, 6 a.m. morning, 10 a.m. night, at any time. On-demand self-service. 24 hours it is available. Next characteristic of cloud computing is rapid scalability. Cloud, there are some world famous clouds like Amazon and Microsoft, Google. They are rapidly, they are all clouds. If it is a cloud, it must be rapidly scalable. Might be huge burst of data comes, then the cloud must be able to cope up. Okay, measured services, this is another feature characteristic, and pay per use. You will have to pay as you use it. If you are using 1 TB of the storage of the cloud, you will have to pay for 1 TB. If you are using 10 TB of the cloud, then you will have to pay for 10 TB. Okay? Now, cloud computing provides different services. These were the characteristics of cloud. Now coming to the services, very famous services, IaaS, PaaS, and SaaS. Infrastructure as a service, platform as a service, and software as a service. All of you aware of these things. Even then, I think I should tell you in brief, in one line. Infrastructure as a service means you are exploiting the infrastructure of the cloud only. For example, the storage of the cloud only. You have hired 1 TB and you are paying annually for 1 TB. You put, you keep your data on the cloud of vendor. Okay, you access the data, you store the data. That's it. Next is platform as a service. You are using a platform designed, developed by that cloud, by that vendor. Okay, this is platform as a service. Getting the point? Next is software as a service. You are using software, the platform, the infrastructure, everything of that vendor. In real life example, for example, I carry tea leaf, sugar, milk, and keep these to some chai wala, and whenever required I say him, please give me this tea leaf, sugar and milk powder, and I take these things from him and make tea and drink tea, and again the remaining items we remaining, or you can say after adding, we keep again with that chai wala. This is infrastructure as a service. Okay. Second thing is, we say him, we go to the chai wala and use his pan, use his burner, okay, use his gas to make the tea and drink tea and pay him for that. This is platform as a service. And the third is, we go to chai wala and say, भैया 2 कप चाय बनाना. That's it. We order the tea, he will make the tea, he will serve you on your table, you will drink the tea, you will take the tea, and you will pay for the tea and leave the hotel. This is software as a service. This is very real life and simple example of IAS, PAS and SAS. Got the point? Now, third point was big data analytics. In last lecture, I have told many times, again and again, this word comes, big data, large volume of data. It refers to the method of studying massive volume of data or big data. Collection of data whose volume, velocity and variety, these are the important features of big data. Volume, velocity and variety. Now there are some more V's, veracity and etc. These are three basic three V's. These are three V's: volume, velocity and variety. Three V's of big data. Is simply too massive and tough to store, control, process and examine the data using traditional databases. If I talk to you about 10 years back, banking system of 10 years back, there was not a big data. Banking was computerized, but there was not big data. if we if you remember, um, banking was done in the banks only, and then it is modified and came to the ATM in nearly um, 25 or 30 year back. ATM were introduced. Otherwise, computerized banking was introduced by Rajiv Gandhi in 1983 or 84, sorry, 85 or 86, 86 I think. So in those time, banking was computerized, but it was not a big data, because banking was done in the bank only, and there is a queue. One person is coming, it's his transaction is done, then next person will come, his transaction will be done, and so on. But nowadays it has volume, it has velocity, it has variety. In 1986 or 1988, neither it was having velocity, neither it was having volume, neither it was having variety, because one person was coming at a time. Okay, no velocity was there, no volume was there. Now one person is making hundreds of UPI payments in a day. 1 rupee, 2 rupee. He is taking 5 rupee pan masala and giving through UPI. Sometime Amazon gives an offer of send money 10 rupees, you will get some, what you say, reward, maybe in the form of cashback. Some people send, A is sending to B 10 rupees in three different transactions through UPI, and he is totally transferring 30 rupees in three transactions and getting 11 or 12 rupees cashback. And again B is transferring 10 rupees three times to A and getting 9 or 10 or 11 rupees cashback. Just be fooling the company. They are A transferred 30 rupees to B, and B had given back 30 rupees to A, and both of them, A and B, got 11 or 12 rupees cashback. So anyway, I mean to say, sometime before I went to bank to print my passbook, he said it is very difficult to print the passbook, because everyone is making 1 rupee, 2 rupee, 5 rupee UPI transaction every in 20 or 25 transaction per day. We will have to print not the passbook but the registers for this. Okay, so huge volume of data is there, velocity is there, data is coming rapidly. In one server of a bank, thousands, lakhs of transactions are being done in 1 second. If 1000 account information is kept in one server, in 1 minute thousands of transactions are being done. Okay, and variety of data is there. Big data is gathered from a variety of sources, including social network videos, digital images, sensors, sales transaction records, etc. If you see some t-shirt or some shoes in Amazon. After 1 minute, when you log in the Facebook, you will see the ads of shoes. This is the velocity. Getting the point? Variety. Okay. Anyway, this is huge subject in itself. Several steps involved in analyzing big data. Data cleaning. Data comes in raw format. It is cleaned. It is filtered. Okay. Then it is munged. Data munging. Converting raw data into some suitable, usable formats. Okay. Then data is processed and data is visualized in the form of likes, dislikes, whether this person is wanting shoes, or he is disliking red tape, he is liking Reebok, he is liking Skechers, and he doesn't like Pepe, he doesn't like Levi's, etc., etc. And one more thing, big data can be in the form of text. This data can be in the form of images. This data in the form of expressions. This data can be in the form of voice, etc., videos, etc. Examples of big data are bank transaction. Bank transaction of nowadays, not of 88 and 89, 1988 and 1989. Nowadays, bank transaction is big data. Data generated by IoT systems, obviously, for location and tracking of vehicles. E-commerce sites. This is very big data. I think lakhs of transactions are executed within 1 minute, within not only 1 minute, in 1 second, in only Lucknow city. Getting the point? E-commerce. Everyone is accessing Amazon, Flipkart, Meesho, and I don't know. There are hundreds of e-commerce websites, and that I know, Amazon, Flipkart, or Big Basket, and all that. There are some specific e-commerce websites for B2B, B2G, and many more. Okay. Health and fitness data generated by IoT systems such as fitness bands. They also give information to the concerned institute, concerned doctor, concerned person about the fitness, about the health of the data of the patient. Next is communication protocol. It's a very important thing. They are the backbone of IoT system and enable network connectivity and linking to application. Communication protocols, you all have must have studied this communication protocol in computer networks. Communication protocols allow devices to exchange data over the network. Multiple protocols often describe different aspects of single communication. A group of protocols designed to work together is known as protocol suite, and when implemented in software, they are called as protocol stack. Okay. In one protocol, there are some layers. This is called protocol stack. in one layer some protocols are being used. This is called protocol suite. For example, in network layer, if I talk about TCP IP layer, in network layer there are five very important and major protocols: ICMP, IGMP, IP, ARP, and RARP. This is protocol suite of network layer. But in IP, within the IP protocol, there are some layers, there are some stacks, there are some fields, header length, fragmentation, and so on, type of service, option, so on. These are called protocol stack. A group of protocol, sorry, when implemented in software, they are called protocol stack. They are used in data encoding, addressing scheme, etc. Okay, you all know about this. Next is embedded systems. It is a combination of hardware and software used to perform special tasks. It includes microcontroller, microprocessor, memory, networking units, Ethernets, Wi-Fi adapters, etc. Input-output units like displays, keyboards, etc. And the storage devices. All comprise an embedded system. This is the hardware part, and all this hardware part is a software is embedded to control, to manage uh, these hardwares. This forms an embedded system. Suppose there is a device which is having one input device, one output device, one processing unit, etc. There should be some software which will control all the things. Okay. So embedded system is a combination of software and hardware. For example, there is a washing machine. It is also an example of embedded system. There is a chip, automatic washing machine. There is a chip, and in that chip, some software is embedded. That chip is trained with some software, and now this chip is controlling the washing machine. This is embedded system. Getting the point? It collects the data and sends it to the internet. Embedded systems are used in digital cameras, DVD player, music player, industrial robot, wireless routers, and many more devices. For example, a washing machine, I have told, in refrigerator, etc., etc. These are some applications of wireless sensor networks. It is used in energy control, environment monitoring, entertainment, agriculture, transport, smart cities, healthcare, etc. This is application of WSN, and this is application of IoT. Getting the point? IoT CPS system. CPS is cyber physical system, internet connected. Integration of IoT, wireless devices, and people in the industry. WSN, people, and IoT all are integrated with one, which forms one IoT system. Okay? Is it okay? Integrated services, big data, databases, IoT devices, cloud computing, people, sensor nodes. This sensor node means WSN, and smart factories and all that. Okay? And this is one of the example of IoT based generalized architecture of smart cities, where vehicles, sensors at road, are connected to some gateway, hospitals, cities, classrooms, amusement parks, industries are connected to some gateway, and this gateway is connected to some uh, data center through cloud, and this is the end user. End user can access any of the data, whether end user can, this is a doctor, these are children, which doctor want the data of hospital, he will accept the data through this and this is lady, this want the information about the sale in Big Bazaar or Spencer or in Lulu Mall. So she will get the information from data center through cloud, through gateway, and through and some Lulu Mall or Phoenix Palacio somewhere here. Anyway, these are the children which require the information about the amusement, whether which movie is there in novelty, which movie is running in PVR, in Inox, etc. Anyway, all these informations will be accessed through this cloud, and the cloud will have the information through gateway from these devices, IoT device. This is all about the WSN and IoT. I think there will be no confusion of what is the difference between WSN and IoT device, IoT network, IoT system. Okay, thanks a lot. Any question you can ask.